In this video, we will continue rectilinear motion, but this time with uniform accelerated rectilinear motion and uniform decelerated rectilinear motion. So, we have this experiment. We have a puck moving on an inclined plane from M0 to M7. We have all these traces, and we took the tau. We adjust the tau to 100 millisecond, and this one is accelerated motion. How we know that it's accelerated motion? If you notice that the traces, the first traces are very close to each other, the displacement is very small, within 1 tau. The two other traces are more far with the same tau. The other two traces more far, and so on. We know that the displacement between the two traces is increasing here is increasing since the distances are increasing, and we are covering more distance in same time because the velocity is increasing. The position of each trace, we will take O at M0 at the origin, then X0 is 0, M1 is 3 millimeter. We are measuring them in a ruler. Using a ruler, the distance from M0 to M1 it's 3 millimeter. The distance from M0 to M2 is 11 millimeter. The distance from M0 to M4, it is 43 millimeter. The distance from M0 to M5, 66, and so on to M6, 95, and to M7 it's 128. Of course, we have reading error. We will try to eliminate as much as we can my reading error. Now we will take the time. As we said, we start timing at the beginning at M0. It's 100 millisecond the tau. We took 100 millisecond the tau. So at T0 is 0. At T1 at M1 is 100 millisecond. Of course, M2 200, 300, 400, 500 till 700 millisecond. We reach to M7. Now we will try to calculate the displacement between two traces. As we said last time, xi minus 1, yani x1 minus x0, x2 minus x1, and so on, to have the displacement between two traces. Last time it was constant. Now we notice that it is increasing, the distance is increasing, and we will check the numbers. So here at M0 we cannot, since we don't have anything before M0. Then we will start from x1. So M1 here, x1 minus x0, it gives me 3. In here 3 millimeter the distance between M0 and M1. M2 yani x2 minus x1, x2 minus x1, the distance between M1 and M2, which is 11 minus 3, it's 8. M3 here, x3 minus x2, 24 minus 11, 13. At M4, x4 minus x3, the distance between M3 and M4 is 43 minus 24, it's 19, and so on. Here 66 minus 43, 23, 95 minus 66, 29, and 128 minus 95 is 33. As we notice that the displacement between the two traces is increasing, 3, 8, 13, 19, 23, 29, and 33. This indicates that this motion is accelerated. The velocity is increasing. We notice this by checking the displacement point between two consecutive traces. Of course, now we will check the instantaneous velocity. Instantaneous velocity, as we said last time, xi plus 1 minus xi minus 1 over 2 tau. عم ناخد قبلها بنقطة وبعدها بنقطة وعم ناخدها على 2 tau لأنه we are taking 2 tau as displacement 2 tau. Okay, this is the time we are taking. First, we will start with V1. As we said later, V0, we cannot calculate V0 because we don't have the position before M0. So we will take V1. V1, I will use x2 minus x0 over 2 tau. x2 minus x0 over 2 tau means 11 minus 0, but millimeter, times 10 to the power minus 3, over 2 tau. Over 2 tau, we have tau 100, 2 times 100 كمان times 10 to the power minus 3, so 10 to the power minus 3 بنكنسلها بيطلع معنا 0.055 meter per second. V2 هو x3 minus x1 24 minus 3 over 2 tau. كمان ما ننسى الملي بيطلع عندي 0.105. V3 كمان x4 minus x2 على 2 tau 43 minus 11 على 2 tau. 2 tau over 200 بيطلع معنا 0.16. V4 هو x5 minus x3 over 2 tau 66 minus 24 over 2 tau بيطلع معنا 0.21. V5 is x6 minus x4 95 minus 43 millimeter على 2 tau كمان طلع 0.26 and so on. So the last one we cannot calculate it. Okay, this is empty. Now we can calculate the acceleration. The formula of the acceleration is vi plus 1 minus vi minus 1 على 2 tau. This is now we are dealing with the variation of the velocity. For that, we are unable to calculate also V1, A1. A1, we are unable to calculate it. And also A7 and A6, we are unable to calculate them because we don't have velocity. A7, we don't have velocity at all for V8. And we have for V6. For A6, we don't have V7. Because we need V7 minus V5. A1, we don't have V0 because we need V2 minus V0. So we are unable to calculate A1, A6, and A7. We can calculate A2, which is V3 minus V1 على 2 tau. V3 0.16 minus 0.055 على 2 tau. Now you should take care about the millisecond of the time of the 2 tau because we don't have any more milli in the numerator, so we should keep the milli in the denominator as 10 to the power minus 3. Okay, here 0.16 minus 0.055 على 2 tau, 2 times 10 to the 2 times 100 times 10 to the power minus 3 بيطلع جواب 0.525. Okay, A3 is V4 minus V2 على 2 tau بتطلع 0.525. A4 is V5 minus V3 على 2 tau بيطلع 0.5. And A5 is V6 minus V4 على 2 tau كمان طلعت 0.5. Approximately they are equal acceleration. Okay, as we said last time, we have reading error. Okay, and we can suppose that the acceleration equal to 0.5 meter per second square. For that here, we call this motion is uniform accelerated rectilinear motion. Rectilinear since it's a straight line. Uniform accelerated. Now uniform is related to the accelerated, not to the motion. In the last video, uniform rectilinear motion, the uniform is related to the motion. It means that the motion is uniform, yani the motion and the constant velocity. Now the uniform is related to the accelerated. Uniform accelerated since the acceleration is constant, equal to 0.5 meter per second square. Now, if the acceleration is not constant, if the acceleration is 0.5, 0.7, 0.8, 0.9, like this, it's arbitrary, not a constant, then motion is not uniform. It's accelerated rectilinear motion without the name uniform. Here, yes, we have a constant acceleration, then our motion is uniform accelerated rectilinear motion. In the same way in this table, if the motion is decelerated, instead of writing m0 to m7, if we write here m0 to m7, then here the distance between the traces is very large, then it's smaller. Okay, here the velocity is decreasing and the motion is uniform decelerated rectilinear motion, and we notice that the velocity will be decreasing, not increasing as we get in the table here, and the acceleration will become negative, okay, not positive as here. Now the characteristic of this motion. The trajectory of a body is a straight line. هيدا بنسميه the motion is rectilinear. The distance covered in each of the equal interval of time is not constant. Then the instantaneous velocity is increasing and the acceleration is constant. As we said, if the acceleration is constant, then the motion is uniform accelerated rectilinear motion, UVRM. If the acceleration is not constant, but the velocity is increasing, then the motion is accelerated rectilinear motion, ARM, without U. Now I will try to draw the graph for the acceleration, for the velocity, and for x, the position, as we did in last video for uniform rectilinear motion. The acceleration now is constant. The acceleration is constant. It's 0.5 meter per second. So it is a straight line, constant straight line, and A is the constant. It's 0.5 meter per second square, or 1 or 2, any constant. From the table, it's 0.5 meter per second square. This is first graph. Second graph, velocity. From the table, as we calculated the values for V1 and V2 and V3 till V6, so we will take the values from the table. First 0, 0, this is first 1, second 100 millisecond, it was 0.055 meter per second. Second one, 200 millisecond, our value was 0.1 meter per second, and 600 millisecond, 0.3 meter per second, and I can draw the graph, which is a straight line. Here also, I started 0, 0, as if the puck starts from initial velocity equal to 0 meter per second at released from rest. But it's not always the case. عمرها ما بتكون start from rest. So sometimes initial velocity, we have initial velocity v0 is 1 meter per second, 2 meter per second, as the given. So if it is not the case that it start from rest, it may be start from v0, whatever the v0 is, 1 meter per second or other values. Okay, as we said, this one is a straight line. So the equation of a straight line is what? The equation of a straight line is y equal ax plus y0. But now here, the y-axis, we are using it as velocity, and x-axis, we are using it as time. So y equal kx plus y0, y I will substitute it by velocity, and x I will substitute it by time, and k is my slope. So v equal kt plus v0. By the way, what's the slope here? k is the slope here, yes? Slope here delta y على delta x. Delta y على delta x, the y I substituted by velocity, and x I substituted by time. delta y على delta x يعني delta v على delta t. Delta v على delta t represents what? Yeah. Delta v على delta t represents the acceleration. Okay, k هي delta v على delta t, it's our slope, which is the acceleration. And a new time equation for uniform accelerated rectilinear motion is v equal at plus v0. At plus v0, this is the first time equation for uniform acceleration rectilinear motion. v equal at plus v0. v is the velocity at any time or at any instant we want to calculate. A is the acceleration. T is the time that we need to calculate this velocity. If v1 يعني t is 1 second, if v2 t is 2 seconds, and v0 is the initial velocity. If it is start from 0, then v0 0. If it didn't start from 0, then v0 is a constant that we will take from given. So here, of course, we are dealing with acceleration is a constant acceleration, since we said it's a uniform accelerated rectilinear motion. Now, the last graph for x, the position. If we will take the values from the table also, first 0 0, second a 100 millisecond 3 millimeter, third 200 millisecond 11 millimeter, 695 millimeter, and it's enough to know that it's not anymore a straight line, it's a part of parabola. It's part of a parabola, and we are unable now to check the equation of this one. Okay, no more a straight line, but we have an equation. We should memorize this equation in this year. Next year, I hope we will know how to calculate, how to derive this equation, but in this year, we should memorize this equation. So the graph is not a straight line. X equal what? It's so easy. We will try together to memorize this equation. X equal half a t square plus v0 t plus x0. That's it. So half a t square plus v0 t plus x0. X is the position at any instant we want. Half a, that's the acceleration, t square, the time square, plus v0. If it is 0, this term will disappear. v0 times time, the initial velocity times time, plus x0. Also, if x0 is 0, then this term will disappear also. So these v0t plus x0, these are initial condition for the initial velocity and initial position. If x0 is 0 as the green graph, then x0 we will cancel x0. If we have the graph as the red one, no, we are unable to cancel x0. We have value x0. We should add it here as x0. So time equation for uniform accelerated rectilinear motion is half a t squared plus v0 t plus x0. This is last formula for uniform accelerated rectilinear motion. If in any problem we don't have time, we no need to calculate the time, we can use this equation, v square v final square minus v0 square equal to ad. A is the acceleration, d is the displacement, x minus x0 is the displacement. So this equation, we use it whenever we don't have time in a problem. So if a dot v greater than 0, and if a is positive and v positive, then the motion is uniform accelerated rectilinear motion. So this is first case. If a dot v less than 0, if a negative and v positive, then it is uniform decelerated rectilinear motion. And by the way, the three equations for uniform accelerated rectilinear motion, we will use them the same in uniform decelerated rectilinear motion. Okay, no need to change them, only the acceleration will be negative. Now, here a dot v is positive if a positive and v positive, but also we have another case if a is negative and v also negative. And if we are moving in backward motion, then here the motion is uniform accelerated rectilinear motion, but in the negative sense. And as if we are moving backward in the negative sense, the motion is accelerated. يعني أنا عم بمشي لورا، okay, in the negative sense عم بسرع، بس in the negative sense يعني my acceleration will be negative and the velocity will be negative. If the acceleration and the velocity have same sign, plus plus or minus minus, then the motion is accelerated. If a and v have different opposite sign, a negative, v positive, then uniform decelerated. A positive, v negative, then it is uniform decelerated, but in the negative sense. I will let you see this figure to illustrate this idea. Here a car moving in the positive sense, velocity, forward, and he reduces his speed when he reaches the mud. So the velocity is decreasing, slowing down. So the acceleration is opposite to the velocity. Acceleration negative, velocity positive, opposite sign A and V, then A dot V is negative, then the motion is uniform decelerated rectilinear motion. So here the motion is uniform decelerated rectilinear motion. This is here the motion forward in the positive sense, but it is uniform decelerated rectilinear motion. Now he reaches to a ground, okay, and speeding up, and the velocity is increasing. The velocity is increasing in the positive sense, still moving forward in the positive sense. So the acceleration is positive. The velocity and the acceleration have same sign. So A dot V is positive, then the motion is uniform accelerated rectilinear motion in positive sense. Uniform accelerated rectilinear motion in positive sense. Here, in positive sense, the motion is uniform accelerated rectilinear motion. وبعدنا ماشيين in the positive sense. بس انتبهوا هوني الاكسلريشن والفيلوسيتي in the same sense. هوني الاكسلريشن والvelocity in opposite senses. Third picture, the car came back, okay, and it's slowing down through mud. So the velocity is in the negative sense. The velocity in the negative sense. Here, the velocity in the negative sense بعكس ال positive sense اللي كان to the right. اخدين نحن ال positive sense to the right. Now the velocity in the opposite sense يرجع على الطريق. So this one, the velocity is negative. The velocity is negative. But it's slowing down. يعني ال velocity and the acceleration are opposite. يعني here the acceleration is positive. Acceleration positive, velocity negative. A dot V is negative. يعني uniform decelerated rectilinear motion, but in which direction? Here in the negative direction, backward. Here in negative direction. يعني the motion here, the motion is uniform decelerated rectilinear motion in negative direction. Last picture, speeding up. It starts speeding up, still in the same direction in the negative sense, negative velocity in the negative sense, to the left, the car moving to the left, and we are taking the positive sense to the right. For that, the velocity is negative. The acceleration is negative. So the acceleration and the velocity have same sense, same direction. يعني A dot V minus times minus is positive. A dot V is positive, then the motion here what? Uniform. Here the motion is uniform accelerated rectilinear motion, but in which direction? In the negative direction. Here in the negative direction. Negative direction. So uniform accelerated rectilinear motion in negative direction. So to sum up this idea, here, whenever I have A dot V greater than 0, يعني A, the velocity and the acceleration have same direction, then it is uniform accelerated rectilinear motion. If A dot V negative, يعني A and V, the acceleration and the velocity, have opposite directions, then uniform decelerated rectilinear motion. ومين بيحدد لي إذا أنا ماشي in the positive sense أو أنا ماشي بالنيجاتيف sense؟ بيحدد لي ال velocity. إذا ال velocity positive, then I'm moving in the positive sense. وإذا ال velocity negative, I'm moving in the negative sense. ال velocity بتحدد لي which direction وال A dot V بتحدد لي شو هي type of motion. So to sum up the two videos, uniform rectilinear motion, velocity is constant, acceleration is 0, and I have time equation وحدي اللي هي x equal vt plus x0. This is the only time equation in uniform rectilinear motion. Uniform accelerated rectilinear motion, عندي acceleration equal constant لأنه uniform accelerated, velocity equal to at plus v0, and x equal half at square plus v0t plus x0. And again I will say these formulas applicable for uniform decelerated rectilinear motion, same. And we can say uniform varied rectilinear motion instead accelerated, لأنه decelerated و accelerated, instead of them both we say uniform varied rectilinear motion. And the last formula, v square minus v0 square equal to AD, this also for uniform accelerated rectilinear motion and uniform decelerated rectilinear motion. Here V equal AT plus V0 and X equal half AT square plus V0T plus X0. These two equations are, we call them time equations for uniform varied rectilinear motion. Okay, rectilinear motion, I mean by it uniform accelerated rectilinear motion or uniform decelerated rectilinear motion. Okay, these formulas for both, and that's it. You can start with the application now. Thank you.